Okay, now it's going. Hopefully these videos for the old lectures will help you out. Okay, let's start off with a graphical vector problem. Okay. You can do this without doing the graphs, but let's just try to do it with graphs, okay? So let's see, here's the example. Let A be the vector 2 meters, so by 1 meter, 2 meters comma 1 meters, and B is equal to 0 meters comma 2 meters. And the question is find A minus B, this time using graphical methods, using graph, in other words, drawing and laying vectors out. Okay. And so I'm going to make some plots. So each tick on the x-axis and the y-axis, each tick is 1 meter. And the choices will be okay, this requires drawing a lot of stuff here. Multiple choice graph stuff is kind of a pain. 2, 3, 4. Okay, one would be here. Okay, the other would be 1, 2, 3, 4, 2, 3, 4, 2, 3, 4. And this would be the other one. Okay, it's going to be hard to fit this all. Let me make it a little smaller. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and this one's up here. B would be 2, 3, 4. 1, 2, 3, 4. From here, there. I'm running out of space for E, but E was the wrong answer, so I'll just leave it off. Okay. Okay, go ahead and click in. So if you really don't actually know the answer, you can check your work by using adding complements. You can use complements and check your work. Okay, I'll wait another 30 seconds. Yeah. Oh, you can use it again. Yeah. By the way, if you press the wrong answer, just press another answer. Hopefully, it's the correct answer. Okay, everybody's made a choice. All right. Pretty good. Okay, let's see what people said. All right. A lot of people say B. Let's go through. Okay, so we say, let's just draw the vectors. So we said A was 2 meters, comma 1 meters. B was 0 meters, comma 2 meters. Okay, thank you. That's the first time I was too high. Okay. All right. So 1, 2, 3, 4. 1, 2, 3, 4. 2, 3. Okay, put some more over here as well. So A is 2. I go 2 in the x direction, 1 in the y direction. So A looks like this guy. Sorry, it's a bit small. Okay, so that's my A. Now B, well, I actually don't want B. I want to do A minus B. And so that's A plus negative B. So negative B is going to be, let's just do it in terms of components, it would be 0 minus 2m. Okay, so just be the reverse of B. Now what we're going to do is we're going to go from the end of A, or what the book calls the tip of A, and go in the negative B direction. So I'm going to go 0 in the x direction, minus 2 in the y direction. So it will go like this. So that's my minus B. Everybody's good on that? Okay. And then this is the starting point. That's the start. And here's my end. And so all I need to do is draw the vector from the very start to the very end. And that vector is A minus B. Okay. Questions? We can check it also. If I'm adding the vectors together, A plus negative B, I get the components, A minus B, will be 2 plus 0 is 2. 1 minus 2 is minus 1. So it's 2 comma minus 1. So you can go that way as well. Okay. Any questions? Yeah. Yeah. You can call the x and y components. You can call them I, j. Okay, let's go on. Next example of a different kind. Let's say, given that 1 mile, 1 mi, is equal to about 1,609 meters, the speed of 55 miles per hour is equal to, by the way, the abbreviation for hour, sometimes you see it as H, sometimes you see it as HR. I've seen both. So. It is equal to what? Let me give you some choices. 15 meters per second. B is 25 meters per second. C is 66 meters per second. D is 88 meters per second. And E is 1,500 meters per second. Okay, and I'll open up Poland. So remember, speed is the magnitude of velocity. Bring these terms. Okay, everybody had a chance to respond? Let's see what people have said. All right, a lot of people say B. That's good. Okay, so let's take a look. So we're converting. I like to use the substitution method where I just write down the thing. You can use the fraction method if you prefer. Whatever method's fine. So the mile, so 1 mile is equal to 1,609 meters. 1 hour is 60 minutes, which is, and each minute is 60 seconds, so it's faster just to go directly to 3,600 seconds. 1 hour is 3,600 seconds. And so 55 miles per hour is 55. Let's get this out of the way. 55 times 1,609 meters divided by 3,600 seconds. And you punch that into your calculator, and it comes out to about 25 meters per second. Anybody have a question about this? Yeah. So I rounded it to 2 significant digits. If you rounded, do you also get that?
I think so, yeah.
Yeah, okay. Okay, let's go on. Completely different kind of problem. I'm jumping around just to it's kind of like the quiz. The quiz will jump around in different topics, okay? Okay, the position of an object is given by x of t, so it's a function of time, is t cubed minus 2t squared plus 15t plus 4, where x is in meters and t is in seconds. The velocity, let's say the vx for the x component, keep going, right? Vx at t equals to 2 seconds is what? I have to give you some choices. 8 meters per second, B 17 meters per second, C is 10 meters per second, D is 19 meters per second, and E is 30 meters per second. I'll open up polling now. I'll wait until it goes over 200. Okay. Everybody good? Let's see what people said. All right, a lot of D's. Okay, so velocity. Velocity is the derivative of the position. So v, let's put an x there just to be clear. We're looking at the x direction. That will be the time derivative of x. So I need to take the time derivative of this function. All right, let's do the first guy. So let me write it here so it's close by. T2 plus 15t plus 4. Okay, so let's do the derivative. T cubed, that derivative is 3 times t squared. You take the exponent, multiply it out in front, reduce the exponent by 1, so it's t squared. Then minus 2, oops, there's being 2t squared. And so the 2 from the exponent multiplies the 2 that's already there. There's a minus sign, don't forget that. I get 4 times t. And then I have 15t, so that's t to the first power. The 1 basically, that doesn't really do anything. So then I have 15 times t to the 0th power, which is just 1. And then I have 4. The derivative of 4, though, is 0. So now what I'll do is I will take, at the time t equals to 2 seconds, and then plug it in. I get 3 times t squared minus 4 times, sorry, not t, but 2 squared minus 4 times 2 plus 15. So I get 12 minus 8 plus 15. So that's 4 plus 15, which is 19. And the units I'll put in is meters per second. Okay. Everybody good on that? Yeah. It's multiple choice. Yeah, yeah, every multiple choice. Okay. Other questions? Okay, let's go on to the next one. This one is a more conceptual one. By the way, the problems we're doing today are a little bit on the easy side. They'll get harder tomorrow. The following is a motion diagram. Here's a motion diagram at evenly spaced time intervals. So that's what a motion diagram is. Okay, and let's say this is the positive x direction. And we have a line here. This is time 1. This is time 2. This is time 3. This is time 4. And time 5 will be somewhere way out here. Okay, so then if I'm drawing arrows like this. And the question is, quite simply, which is true? And we have A is Vx greater than 0, Ax, acceleration, greater than 0. B, Vx is less than 0, Ax is less than 0. C, Vx is less than 0, Ax is equal to 0. D, Vx is less than 0, Ax is greater than 0. Or E, Vx is greater than 0, Ax is less than 0. Okay, go ahead and make your choice. meters. Okay, let's see what people have said. Okay. All right, so there's B's, but there's some D's also and others. Okay, let's take a look. Okay, now, because people like B's and D's, I think everybody agrees maybe that the velocity is going in this direction, so it's negative, okay? So solution. All right, so we have this situation. 2, 3, 1, 2, 4. That's too many points now. Okay. Oh well. 3, 4. Let's say 5 is here. We'll just stop there. Okay. And so these are the actual positions at the various time snapshots. Okay. And so this will be, right, just when you think about the velocity, let's say in this interval, it will be equal to the displacement divided by x, divided by delta t. Okay. The delta x over delta t. If you don't like me putting all these vectors on, just dx is equal to delta x over delta t. Okay? Now, because it's going to the left, this delta x will be negative, and that's why dx will be negative. Everybody clear on that? Okay. Now, the thing that might be confusing you is the acceleration. So now, let's think about what is acceleration. So let me just give you numbers. So let's just give numbers here. Suppose this vx here at this point was minus 2. Okay? But just say it's minus 2, just to make it clear conceptually what I'm talking about. Then this one, Vx, should it be more like minus 1 or should it be more like minus 3? Okay, minus 3. Okay? So that's the way I think about it. So then how about this one? This one be like Vx is equal to minus 4. Okay? So now, if I'm calculating the acceleration, what I need to do is find the change in the velocity. Okay, so in other words, I need the delta Vx over delta t, and that's final minus initial. So I need minus 3 minus negative 2 over delta t. Okay, everybody got that? So is this guy going to be positive or negative? Yeah, so that's going to be negative. In fact, I'm getting minus 1 here. So the point is that this Vx is negative. The next Vx is also negative, but it's bigger in size than the previous one. So when you subtract the two numbers, you end up with a negative number. Does that make sense? Okay. So if you're trying to get this conceptually down, just think about if I have some velocity going in one direction, if the acceleration is also in the same direction, it gets faster than it was going before. But if the acceleration is going opposite, it will slow down, and then eventually it reverts. Does that make sense? This is true even if it's going in the negative x direction. So, any questions about this? If you're not sure what the answer is, just simply do what I did here. This is a foolproof method. Just think about what is the velocity here, what's the velocity here. If I subtract them, will I get a positive or negative result? And that gives me AX. Any questions about that? Are we good? Okay. We can do more like that later. Let's go on. Okay, this is a constant acceleration problem. A ball is thrown straight up into the air with speed 14 meters per second. How far does it go before reaching maximum height? Okay, how far does the ball go? Answers are 40 meters, 27 meters, 10 meters, 16 meters, 35 meters. Okay. Go ahead and, oh, I didn't press it. Let's do it again. Yeah, I'll give you another 30 seconds. Okay, 10 more seconds. Give it your best shot. All right, 5, 4, 3, 2, 1, and I'll close it up. Let's see what people said. All right, a lot of C's. Okay, let's take a look at this. So let's think about this problem. So the ball is so this is the solution. The ball is thrown straight up with 15 meters per second. Sorry, why did I say 15? 14 meters per second. So let's take this to be the positive y direction. And what the ball will do is it'll go up and up and up until it reaches the maximum, and then it will turn around. Okay? And we're going to stop it right at the top. And right at the top, what will the velocity be? Okay, that's what's called a turning point. And so this will be the initial velocity. Okay, this 14 meters per second. And then this will be the final velocity. And we just call it plain old v when we do the way I write the equations. The way it will be on your formula sheet, it will have all these like v final and v initial stuff. But the way I write it is plain old v. And so the final speed, speed or velocity will be 0 meters per second. Okay. Now, what do we want to know? We want to know how high does it go. So the question is, if it starts here, and what is this delta y? Okay. So let's take inventory of what we know. We know, okay, because it's a gravity problem, we know the acceleration, right? So what is it?
Negative 9.8 meters.
Perfect. It's negative, AY is negative 9.80 meters per second squared. We know V0 is 14 meters per second. We know V final is 0. And we want delta y. So the perfect equation is something that has the thing we want and also only the things we know. Okay? And the equation that does this is going to be v squared minus v0 squared is equal to 2ay times delta y. Alright? Are you good on that? These equations will be given on your equation sheet. On your equation sheet, it will be written a little bit differently, maybe. This guy may be on the other side of the equation, but that's not so bad. Okay. So we're going to plug in the values. We have v is 0 minus v0 squared, so we have 14 meters per second squared. And so this is equal to 2 times ay, which is negative 9.8 meters per second squared, times delta y. So this is going to be, with the minus sign, it's going to be negative 196 meters squared per second squared. And it turns out the numbers actually end up kind of cool here. You get times delta y. And you can do that division in your head. It ends up being delta y is equal to 10 meters. Okay? Any questions about this? Okay. You guys like this, doing these problems? Is it useful? Okay. Let's do a different kind of problem. Another vector problem. All right. Okay, it's a pretty straightforward problem. We have V1 is like this and V2 is like this, all right? And I draw it to scale, everything's to scale. Question is, what is the direction of V1, V2 minus V1? Okay? And the realizing my solutions, I did the other problem. Okay. I have to decide which one I want to do. In my solutions, I did V1 minus V2. All right, let's do V2 minus V1. Let's do V1 minus V2, okay? Since my solutions are crooked for V1 minus V2. I'll fix the the notes for the quicker questions later. V1 minus V2. This is the one that I actually do the solutions for. Okay, V1 minus V2. And the choices are like that. Like this. C is like this. D is like this. And E is like this. Okay? And I'll open up the polling. Let's go close, sorry. And this is there it goes.
No.
So you're subtracting, so you have that, and then you have that, right, and then you just be left off right now.
Okay. Everybody made a choice? Wait another 10 seconds. Two, 1, 0. Okay. Let's see what people have said. All right, a lot of D's. Okay, so let's go over solution. All right, we want V1 minus V2. That's the same as V1 plus the negative of V2. Okay? So we have, you can still see this here. So V2 kind of looks like, the negative V2 looks like this, going opposite in direction to V2, same magnitude. So I'm going to take my first vector, which is V1, and just draw that. That's my V1. And then I will draw my negative V2 starting from the tip or the end of V1 and just draw my negative V2. And then I take the start, I go to the end, be a little bit more like that. And that will be my vector V1 minus V2. Okay? And that's the one we wanted. Any questions about this? All right. Let's take one more. And this one, I'm going to be lazy. I'm just going to throw up the notes so that I don't have to draw it again. I know, I'm being lazy. I'm going to zoom out a little bit. Oh, it doesn't quite fit. Okay. All right, so what I'll do is, the whole thing doesn't quite fit on one. But the drawing is, we have, and then t equals to 0 here, x is also equal to 0, then we have like this. Okay. All right, that's this drawing, and that's the positive x direction. This is the positive x direction. The question is, for this motion diagram, what is a possible sketch for x of t? So I want to know x of t versus time. Okay, and I'll open up the Poa now.
Parallel lines here.
Okay, I'll wait another 10, 15 seconds. Okay, if you haven't clicked in, go ahead and make a choice. And let's see what people have said. All right, a lot of C's. Okay. The point is that our diagram we have something like this with evenly spaced intervals. Evenly spaced points. And this is t equals to 0, x equals to 0, then it starts getting bigger. Okay, so here we have, it's moving even amounts of intervals of space, so this is constant velocity, constant vx. And it's also greater than 0, by the way. Okay. And over here, it's getting faster, so we have acceleration. We have acceleration ax, and it's getting faster. It's positive. Okay, everybody's good on that? Okay, so if I'm going to draw what x looks like versus t, first of all, it has to go through the origin because that's what I have here. But over here, we have a slope that must be positive, so let's make it like this. So that's a constant velocity means you have a straight line for x versus t. Now, when we have a positive acceleration, that means the slope is tending to be more and more vertical. Okay, it's bending. So it's going to bend. It's going to do something like this. All right. Any questions about this? Yeah, question. Yeah. The thing is, it's always gradual, so you can't tell exactly what it is. Okay, so remember to keep up with the homework. One of the things about the math physics is you got homework due every time before class, right? And then you have that monster homework assignment that's due on Sundays. And so you can get started on those ahead of time. You guys tomorrow.
Yeah, the last one was like 5 hours.